Hello everyone, let's talk about the second part. We have already discussed in part 1, so where we are in a linear regression. So let me explain. We have to discuss in this part two topics, two subtopics. You can call it as an embedded one. So that is blue and line. We need to always remember these two things if you are going to perform linear regression. So we have blue and line. What do you mean by blue and what do you mean by line, right? So this has to perform one after another. I mean to say, if we successfully met or successfully attempt these things, so we have to go for line. So this is particularly for residual analysis. So let's revise previous chapter, previous part. So we have done or we have completed the line blue test. So I will walk you or revision for that previous part also. So blue means blue based, this linear unbiased estimated. So we can call, what do you mean by unbiased? Do you have any unbiased means that we take random sampling, right? So that is considered for unbiased. There is no bias at all, right? Each time when you randomly take units, right? No, you are not into the bias, right? It comes one time one thing and other times for other thing. So let's perform small steps for bias. Suppose you are going to linear regression, right? You have two variables. One is a education level and other is a income. So if you think that education level is a predictor, so definitely income is a predicted value. That's what you are going to see. How much person is educated, the more he might earn the money. So that's what the analysis might be. The analysis might be the different if we go through or perform the entire analysis. So let's assume that we have two variables. One variable is education, another is income. So we are going to perform a linear regression. Before, see, I say this is DB. DB is income and IB is education, right? So we can call this as a predictor also, and this as a predicted one also, DB, right? So for that, first of all, in blue, in linear regression, I'll write linear regression here. Regression. In blue, let's do blue, then do line, then ultimately we achieve the linear regression, simple linear regression. See, blue means, first what we will do, check DB is linearly distributed or not, let's say. Okay, how will you check? Through plots. We can do right, histogram, and another one is QQ plots, right? QQ plot. See, now histogram means if it is bell shape like this, means this is normally distributed. In QQ plots means if it is diagonal, means this is normally distributed, right? We have to check the diagonal. Now if we assume that by checking histogram and QQ plots, right, the visual graph, we are not able to confirm that this is normally distributed, then what you will do? Then we will do statistical test. What we have already discussed in previously. What is statistical test? That is Safidio, Wilk, normality test. Right? Saphir-Wilk normality test, what it says? P-value is greater than 0.05. If p-value is greater than 0.05, then this is normally distributed. This test also we can say as a GOF test, goodness of fit, right? This Saphir-Wilk test. So your p-value should come more than 0.05. So that case it is confirmed normally distributed. Now second part, what you do in second part, we need to check linearity, right? Linearity of those variables. How will you confirm? Will fit linear regression. We can call y hat equals to a plus bx. Right. Suppose if I talk about some software, our program, how will we consider is our programming. We say model 1 as a variable we define here, then lm as a function, linear model, then we call db first, means income first, then there is a tilde, then which variable? Education. Now give comma and data equals to dt set, like this you can define. So this is the data sets where those variables are inside that file, income and education. Extract those things and make this income as a dependent variable and education as a independent variable. So this is the model. Through model we can confine that or confirm that this linear regression is blue estimated. How? We have to check two things, right? First one is p-value is less than 0.05. Then another thing, what? R square, we need to look for R square, right? 80% something, and we also see F test value, right? So we have to majorly look for F statistics p-value. If it is significant, then this model is blue estimate. Blue. Okay, best linear unbiased estimator. Got it? Now think that those variable I have taken and found to be blue estimated. Now it is blue estimated. Now we go for residual analysis, which we call as a line test. Let's perform line test. For line for residual line, we are using line test. For line test, what you'll do? First, L means linearity. How we will confirm linearity? Through plot also we can confirm linearity. That plot name is lowest scatter plot. Lowest scatter plot, right? We can confirm through lowest scatter plot. That's predicted value here, right? Look at predicted, that is dependent variable I see, predicted value near 0. So if predicted value is near 0, so this is confirmed linearity. In statistical test, how we will perform some dv, suppose dependent variable, what dependent variable? Income, right? Just a moment. Then we talk about income, right? Maybe we do something and then residual dollar mean or something we do mean, right? So if it is 0, means this is confirmed that linearity is confirmed. Residual linearity, we say residual linearity. Now independence, how will you confirm independence between those variables? This is actually used for time series analysis. I can call it time series analysis. If you would like to